Good morning, everyone. Now, today we are going to talk about what is join. As of now, we have seen that we can fetch the data from one table by simply writing select, let's say, ename from employee table, where it will fetch the only name attribute from the employee table. Or I can very well write down select dname from dpt table, where it will fetch only department name from dpt table. Now I have a requirement where I want to find out this employee is associated with which department name. This employee is associated with which department name. So here, by looking at the employee table, I can clearly say that King is associated with department number 10. But if I want to get the information like King is associated with sales department, Blake is associated with sales department, Clerk is associated with sales department, and Jones is associated with research department. So rather than getting the department number, I want to get the department name. Now, employee name is present in employee table while department name is present in DPT table. Now, for this requirement, I need to fetch the details from two tables. One is the employee table, another is the department table. Now, to achieve that, we need to go for join. As of now, we have seen that we can fetch these multiple or multiple attributes from a single table, maybe using group by, order by, or multiple clauses. But now we are going to use the join where we are fetching the informations from multiple tables, two or more than two tables. Let's see how do we achieve that. Now, I want to cut the attribute called, let's say, employee name and department name. But I don't want to cut the attribute as is the way we have it here. I want to cut the attribute by joining the appropriate the attributes here. Now, when you are fetching that information from multiple tables, we need to have the appropriate joining conditions on based on these two tables, using which we can place a relationship between tables. Because what is join? Join is the Join is the criteria, join is the relationship. It's a process of forming rows from two or more tables by combining the content of related columns in the joining table. So we need to have the appropriate joining condition in the where clause, using which we can join those two tables. If you do not specify the where clause, if you do not specify the joining condition, it will go for the Cartesian product. So what is Cartesian product? In the case of Cartesian product, every row of the one table is being combined with all the rows of the other table. Again, I'll repeat, what is Cartesian product? If you do not specify the joining condition, it is going for the Cartesian product. What is Cartesian product? What is Cartesian join? In case of Cartesian product or in case of Cartesian join, every row of the first table is being combined with all the rows of the second table. Let me show you with the help of demonstration. For example, if I go for the Cartesian product, this row is being combined with all the rows of the second table. So this is how the output is going to be. Right? This is how the output is going to be. So every row of the first table is being combined with all the rows of the second table. Right? So this is how the Cartesian product will look like. Every row of the first table is being combined with all the rows of the second table. Right? So if I have 14 rows in first table and 4 rows in second table, it will give you the output as 14 multiplied by 4, that is 56 rows in the Cartesian product. This is just a snippet I have created. But just imagine, if you do not specify the Cartesian join, then it will, if you do not specify the joining condition, it will go for the Cartesian product. And in case of Cartesian product, every row of the first table is being combined with all the rows of the second table. right? So since first table has 14 records and second table has 4 records, it will create 56 rows in the Cartesian join. This is just a snippet of a table, but just imagine if you have thousands of record in both the tables, then it will create 1000 multiplied by 1000, those many rows that being created in the Cartesian product, and it's going to give you very huge output. On top of Cartesian product, wherever the joining condition gets satisfies, only those rows will get selected in the output. Wherever the joining condition gets satisfies, only those rows get selected in the output. So here you can see the joining condition to join employee table and dpt table is wherever the department number of employee table is same as the department number of dpt table, right? If you look at these two table, you can say the department number is the foreign key coming from the department number of the dpt table. So department number of the dpt table is acting as a department number in employee table, acting it as a foreign key here, right? So this key got migrated here in this table. We have already learned, since we have one is to many relationship, primary key of one side, that is department table, is migrating here to many side, which is employee table, right? So we can say employee dot department number is equal to dpt dot department number. That is how the relationship between two table is being established, right? So if I simply write down select employee name and department name from employee and dpt table, it will create a Cartesian product like this. Let me show you. So if I simply write down select e name comma d name from employee comma dpt, it will give you the Cartesian product with 56 rows. So this is not what the expected output. This is not what the expected output. So what do we need to do? On the Cartesian product, we need to write down the appropriate joining condition. So this is what the query we have written earlier. On top of this, I need to write down the appropriate where clause as emp.dpt number, which is the joining condition, dpt.department number. Right? So from employee table, wherever the department number is same, similar which matches with the department numbers DEPT number, only retrieve such records. So if I'll write this particular condition, or if I write this particular joining condition, it gives you the exact output: 14 records, King associated with sales department, Blake associated with sales department, Ford associated with the research department, right? So this is a simple join I have written. This is a equi join I have written, where I have written a simple where clause and simple select clause from clause, and using this simple where clause I'm fetching only the required number of records. So if I do not write down where clause, it is going for the Cartesian product, and Cartesian product will give you whatever the number of records we have it in the first column, it is going to combine with all the rows in the second column, right? And it will give you the wrong number of records, or rather I can say that is how the Cartesian product work. But on top of Cartesian product, you need to write down the appropriate joining condition, so that it will face the retrieved number of records only. So it is giving you 14 employees are there, and this is how the every employee is associated with the appropriate department name, right? Now this is a theta way of writing the query. We can very well write down the query in the ANSI way as well. But before that, let me show you, we can very well give the alias for this employee and department. So instead of writing this employee and department every time, we can very well give the alias to this particular EMP and DPT tables. How do we do that? I can very well write down select E name comma D name from employee. Now instead of writing this employee again, I can very well give the alias for employee as E. Similarly for department, I can give the alias as D. Now, instead of referring EMP and DPT, I can very well refer them with the help of E and D. So, I can very well write down E dot department number is equal to D dot department number. So, instead of writing EMP dot department number and DPT dot department number, I can very well refer to them as E dot department number and D dot department number. Right? It is going to give you the same output. It is going to give you the same output. Now, this is a theta way of writing the query. This is a theta way of writing the query. If you want to write down the query in the ANSI way, same query we will write it down. Just little change we will make it. Let me show you. Little change we will make it. I'll just write down, instead of comma, I'll simply write down inner join, right? I'll have replaced this comma with the inner join, and I have replaced this where with the on. So what I have done, comma I have replaced it with the help of inner join, and where clause I have replaced it with the help of on. On top of it, if you want to have any specific condition, you can very well put where clause after this, right? I can very well put where clause after this, but as of now we will just go for the simpler one. So comma I have replaced it with the help of inner join keyword, and where clause I have replaced it with the help of on keyword, right? This is ANSI way of writing the query. This is a simple join, this is an inner join, and I have replaced this comma with the help of inner join, and where clause I have replaced it with the help of on. On top of it, if you want to have the on top of it, if you want to have any specific condition, we can specify that condition by writing where, let's say, department name is equal to, let's say, sales. Since it's Oracle, we need to give the data case sensitive as is. Okay, so I have given department name is equal to sales. I do not have to write down d dot department name. Wherever we have the same attribute name, there only you need to give the alias to that alias before that particular attribute name. So since department number was there in employee table as well as department table, I have given the alias as e dot department number is equal to d dot department number. Otherwise, for other attributes, for wherever we do not have any conflict, there you do not have to specify the alias. Okay, now if I'll write this query here, it will give you data with respect to sales department only. There are 9 records where we have there are 9 employees who are associated with the sales department. So on top of it, if you want to have any condition, we can very well specify with the help of where clause. In theta way, you can similarly write a query. In theta way, if you want to write a simple this query again in the form of theta, as you know, inner join need to be replaced with comma, and on need to be replaced with the help of where. And since I have one more condition, I'll write down the and operator here, right? So this is a theta way of writing the query. What we have done, comma I have in the inner join I have replaced it with the help of comma, where on I have replaced with the where clause. Since I have multiple conditions, I have separated them logically with the help of logical operator called and. So there are 9 employees who are associated with the sales department. So this is how, this is a simple query, this is a inner join, this is theta way of writing the query, and this is ANSI way of writing the query. Both are industry accepted. Whichever is the whichever you want, you can just go for it, right? Whichever you want, you can just go for it. So both are the industry accepted, theta way or ANSI way, you can go for either of it. So this is a simple join using which I can fetch record from multiple tables.